Hello and welcome. You are looking at translations. Now, translations are one of the 4 different transformations that I will be covering, and in all of them I will be looking at these 3 vocabulary words because they will be used in all of them. The pre-image and the image are the figures before and after a transformation is applied. Now, the 4 different transformation types are translation, like from this object to this object here, where you see how letters go from A to A prime, B to B prime, etc. It's literally moving the object from one place to the next. Reflection, whereas you see PQR flips over this line about, like this line right here, it flips over onto this side and everything kind of gets reversed like a mirror image of it. And this is rotation, where if I took this object and I rotated things over to the side around some point, it might end up with this object right here. Now, those 3 pre-image to image are called isometries, and an isometry is when the pre-image and the image have congruent corresponding parts, meaning the objects themselves are congruent, even if they're a different color, even if they're reoriented a different way or flipped or whatever. They did not change their size in any sort of way. In the pentagons, in the translation, AB, segments AB and A prime, B prime are congruent. Angle D and D prime are congruent here, etc. And same thing here. So all corresponding parts are still congruent, P prime R prime with PR, etc. So these are just different examples of showing you what you have. Now, one that is not congruent is the dilation. Dilation is when you take an object and you grow or shrink it. Even if the angles end up being congruent, like this angle is congruent to this one, well, this segment is no longer congruent to that one. So they are not called isometries anymore because these figures are not congruent to each other, even though they do have corresponding parts, but they are not isometries. Okay, so let's just look straight at translation here. Translation is a shift in an object's location of points in space for any distance in any direction. So instead of space, though, I'm only going to be referring to 2D, things on an XY coordinate plane, such as this one right here. And we are going to translate some objects that are going to move left, right, up, or down, or a combination of any of those. And when you're writing out the rule of this thing, what's going to happen is your points, or in this case a point, will have an XY value, and you're going to apply some sort of translation on it. X will be moved, your point will move a certain direction in X, and your point will move a certain direction in Y. A and B are real numbers that will be applied to this, and they will say how far you move horizontally and vertically to get the translation, to get the image. So let's do the first example here. Let's find the image of point A under the translation here. So A has the point, looks like it's 5, 5. What's going to happen is here's the X value for A and here's the Y value for A in the pre-image. And I'm going to find the image A prime by applying this transformation. I'm going to shift this point 4 units to the right and 2 units down right here. This point ends up being where A prime is. Again, I went 4 to the right and 2 down. Now, if I wanted to do it without a graph and just look at the math, I literally take the X point and I add 4 to it, and I take the Y point and I subtract 2 from it. That's going to become A prime, and A prime is at the point 9, 3, which should match up with this. This point looks like 1, 2, 3, 4, 5, 6, 7, 8, 9 over, and 3 up. So A prime is at that point 9, 3. And all translations will occur the same way. Now, in other examples, such as this next one here, we're going to have more than just one point. We'll have multiple points and translate them all. So find the image of quadrilateral ABCD under the translation here. So in this one, let's do the same kind of thing, and I'll give both examples of it with the math and with the graph. What I'm going to do is take every X value from my vertices. I think that'll be enough. You take A, B, C, and D, and you shift each set of points 4 to the left and 2 up. This will give me the point A prime. B prime is 4 to the left and 2 up, would be right here. C prime 4 to the left and 2 up, and D prime 4 to the left and 2 up. Now, I could have done a whole bunch of points. There are more than just these 4 points on this object. Here's a point I could have gone 4 to the left there and 2 up, but the fact of the matter is, now that I have my 4 vertices, all that's left to do is connect these dots. So it's not too much extra work here. I just got to make sure I get these 4 things connected, and this will be the full image based on the pre-image ABCD. So we found the image, but as far as finding it, it would be best if we found the actual coordinate points. So let's see. For A prime, it looks like I'm at 6 over and 3 up, but 6 to the left, so that's negative 6, 3. B prime looks like 5 over and 3 down. C prime is at 2 over, 4 down, 4 negative. And D prime is 2 to the left, and then 1, 2, 3, 4, 5, 6, 7 up. Negative 2, comma 7. So the math-related idea of this is, again, for every xy point, literally every xy point is going to shift 4 to the left and 2 up. It doesn't have to be on the vertices. It could be this point right here. All of them shift 4 to the left and 2 up. But these ones that we actually calculated would be, for instance, A originally was at negative 2, 1. So negative 2, 1. And for negative 2, I took away 4. And for 1, I added 2. That gives me negative 6, 3. B prime started at negative 1, negative 5. And then I take away 4 and I add 2. And that gives me the point. Negative 1 minus 4 is negative 5, negative 3, etc. So C prime here. So C was at, so basically what I'm doing is I'm taking the original locations of these points, then I'm applying that rule to each of them, and then I'm getting my final image. So it's one of 2 ways. You could do both ways. I'm just showing these ways for this one. Next time I'll probably just do one of them. Take away 4 and add 2. And that confirms the points that we found. Now the last part that I put here was if segments are drawn to connect the vertices from pre-image to image of a 2D polygon, meaning if I connected D to D prime, C to C prime, B to B prime, A to A prime, you get the look of kind of a 3D image. So if you take a look at this here, it kind of looks like one of them cube things. It's a 3-dimensional prism. I have some lateral faces that are going all around, and it kind of gives that appearance of that look. So if you do it right, I mean, look, if you do it wrong, you still might get that look of it. But what's going to happen is these points that I connected here, 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 and here all have the same slope of negative 1/2. Negative 2 over 4, right? So negative 1/2. That's what they should have for that to work out. So it should look like a nice looking 3D image. Okay, here's one last example. The translation image of triangle ABC is triangle A prime, B prime, C prime. Now this time you're actually given the vertices in number form, and then here you have the graph of the pre-image ABC. So what we're going to do this time is write a rule to describe the transformation, meaning this time we need to figure out how those XY points moved. Now the idea behind this one is maybe you've already learned some of the other transformation things. And you didn't know whether it was supposed to be translation or reflection, whatever. Well, this one tells you that it is. So you do know that it's going to be some sort of rule like this. So what I'm going to do is plot these points, A prime, B prime, and C prime, 3, negative 4. And I have to figure out how far they moved. So if you do graph it, then it's just a matter of counting. You go ahead and you say, well, from A to A prime, I went 1, 2, 3, 4, 5, 6, 7, and then 1 down. So 7 over 1 down. And if all bets are off here and you're doing translation and this is an isometry, 1, 2, 3, 4, 5, 6, 7, it should count off just fine here as well. 7 over 1 down, this should be 1, 2, 3, 4, 5, 6, 7 over, and 1 down as well. So it looks like each time I'm adding 7 and taking away 1 to x and y respectively. Now if you did want to do it in a math way, what you would do to find the distance from A to A prime is you want to make sure that you are saying it from pre-image to image. And from pre-image to image, you have to do image minus pre-image. In other words, if A is at the point negative 6, negative 1, B is at the point -1, -1, and C is at the point -4, -3, what I have to do to figure out how this rule works, if I'm going from A to A prime from the x's, I'm going to have to take 1 and subtract -6 for my x value. And for my y value, I'm going to have to take -2 and subtract -1. Again, I'm going from my final result to my first result in terms of that subtraction. So that becomes 1 minus -6 is 7, -2 minus -1 is -1. And that result right there is how much each part was shifted. So x got 7 added and y got 1 subtracted. You want to make sure you don't do it backwards because we're going from image to pre-image, from pre-image to image. See, I just did it backwards. So just be careful on that. Fine.